In this video, we're going to look at the organic functional group of esters. So we'll look at what the functional group is. We'll also look at how they are formed, the reaction that forms them, and how to name them. Esters are derived from carboxylic acids, and so they contain a carbonyl. I'll just draw an ester here, and we'll see what the functional group looks like. So it has a carbonyl bonding to an oxygen, but on the other side, it's going to have an alkyl group. It'll have a carbon-containing group in there. And so the ester functional group is this carbonyl oxygen bonding to a carbon. Doesn't have to be a methyl group, but does have to have a carbon bonding to the oxygen that's bonded to the carbonyl. So that is the functional group for an ester. Now, esters are formed from a reaction between a carboxylic acid and an alcohol. So I'm going to draw out what that reaction looks like. Here we have acetic acid, and we're going to react this with propanol. And I'm going to draw the alcohol, so the OH group is facing the carboxyl group of our carboxylic acid. Should be a 2 right there. CH2, and that's a 2 as well. Wow, those are sloppy 2s. Okay, and then a CH3. Okay, and in our reaction, this will undergo the reaction in an acidic environment where you have heat added. So you'd add an acid to this, you'd heat it up, and you can get this reaction to take place. Okay, now in this reaction, our reaction takes place between the functional groups. So the alcohol from the oxygen from the hydroxyl group of our acid is going to come over here and bond to that hydrogen. And so that hydroxyl group and the hydrogen from our alcohol is going to form water. That's going to be one of our products over here is water. And the other product, the ester, is formed when the oxygen from our alcohol comes over here and bonds to the carbonyl carbon. So when you're writing out these reactions and the ester that's formed from it, it is helpful a lot of times to write the hydroxyl groups facing each other, because then you can kind of squish everything together. So we'll start by writing what we have left from our carboxylic acid there, which is a CH3 bonding to a carbonyl. And that carbonyl carbon is now bonding to the oxygen in our alcohol. So there's an oxygen, and then that oxygen in the alcohol is bonding to a CH2, CH2, CH3. So it just tags along everything else that it is bonded to. And so here we have that ester form there, and you can see right in here is our ester functional group, that carbonyl oxygen carbon bond. So that is an ester. Now, to name esters, their names are sort of derived from the alcohol and the carboxylic acid that formed them. And so when you look at an ester and you're trying to figure out, okay, how do I name this? You have to figure out what part of my molecule came from the acid, what part came from the alcohol. And the easiest way to do that is to find the carbonyl oxygen bond and just kind of draw an imaginary line in between them, because the carbonyl over came from the carboxylic acid and the oxygen over came from the alcohol. Now you're going to name the alcohol part first, and you do that by just counting up the carbons. So in the alcohol we have 3 carbons here, and so 3 carbons is a prop would be the prefix for that, and so we're going to name that as a propyl group. And then we name our acid as the last part. So how many carbons came from the acid? And so we had 2 carbons that came from the acid. And so that is ethane. And you drop the E and add OATE. So propyl ethanoate is the name of this. The common name for this is the IUPAC name. The common name, because we have ethanoic acid, or it's formed from ethanoic acid, we can use the acetyl group for that. So let's see, we have propyl acetate. Remember, the common name for our acid over here is acetic acid. So you drop the ic acid and just add an ATE ending to it to come up with the name, the last name for the ester. So the name of that ester is either propyl ethanoate or propyl acetate. Let's look at one more example of naming an ester. I'll draw one out. This one has a benzene ring in it. Here is our ester functional group right there. Okay, so remember our process of how we do this. We are going to draw our line in between the carbonyl and the oxygen. And so the oxygen over this part is named first because it came from the alcohol. And in this case, we have 2 carbons, so that's an ethyl group. From this part over is from our acid. In this case, since it has a benzene ring with the carboxyl group there, that would be a from benzoic acid. So we put, and this is going to be named second. So we have ethyl as the first part of our name, and then benzoate is how we name that, because we take the acid name, benzoic acid, we drop the ic acid and we replace it with an ATE ending to it. So that's how we come up with, oh, I forgot, I lost my Z in there. There should be a Z in there. So benzoate. Ethyl benzoate is the name from that. Okay, one other thing you need to remember about esters, or that you should be aware of for esters, is that they are found in a lot of fruits and flowers and are responsible for a lot of the flavors and odors. So generally they have very pleasant, fruity or flowery odors to them. Okay, so that is just a little bit about esters, their functional groups, and the formation of them through the reaction between a carboxylic acid and an alcohol.